Aspects Incorporated, makers of the SpinTrak system. Aspects Incorporated was founded in the year 1978 and has been involved in development of high-quality imaging products. We developed the world's first automatic spinneret inspection system in the year 1990 and is still being sold today and used globally. Aspects has established 3 offices globally with dedicated staff to support only SpinTrak systems. The offices are located in New York in the United States, Mumbai in India, and Shanghai in China. SpinTrak is the world's first automatic spinneret inspection system, and till this date stands to be the most sought-after piece of inspection equipment in the man-made fiber industry. As you can see on the right, the SpinTrak is used in a wide variety of applications. The largest application sector is POY and FDY filament yarn, followed by nonwovens, industrial yarns, aramids, BCF extrusion, elastomeric yarns, and bicomponent. Problems with visual or manual microscopic inspection. Visual inspection traditionally has been the lightbox method used particularly in nonwovens applications. Both the microscopic and lightbox methods are basically only go or no-go inspection techniques, and they are highly subjective. Many problems are missed, and there's an element of human error. There is no statistical results or qualitative information given. Both methods are very slow with a high degree of labor. No association of spinneret inspection with production, performance, or quality. Automatic spinneret inspection. The SpinTrak is fully automatic, and it was the world's first fully automatic system introduced into the market. The SpinTrak helps improve the lifetime and quality of the spinneret. The SpinTrak is the most accurate system available because of its variable zoom microscope. The SpinTrak system helps tie in with production quality data. An incredibly revolutionary feature of the SpinTrak is wear detection. And finally, the SpinTrak offers both individual capillary and overall spinneret statistics and tracking. What is the return on investment when you purchase a SpinTrak? First and most important is the SpinTrak helps gain higher yields when the spinneret is kept in like-new condition. The SpinTrak helps extend the running time of the spinneret and the line by less pack changes. The SpinTrak helps you produce higher value added products by continuously having new-like spinnerets in production. The SpinTrak helps with faster startups and smoother runs on the line. The SpinTrak helps save refurbishment costs and purchasing new spinnerets. And the SpinTrak helps reduce the amount of waste fabric produced in production. Here are the SpinTrak measurement components. The main measurement of the SpinTrak is made by the microscope, which contains the CCD camera, a zoom ring, and a front light. The spinneret is placed below the microscope, and there is a backlight on below. As you can see, the spinneret is placed where the capillary appears on the top and the counterbore appears on the bottom. The optical information is passed to a computer, and there is a screen that shows the capillary being inspected in real time. The computer is used to take the data of the camera and process it into meaningful statistics about each and every capillary inspected. Here we can see the benchtop model. The benchtop model is available in different sizes to accommodate small size dies or spinnerets used in Meltblown applications, and fiber or filament dies or spinnerets in the synthetic fiber industry. Here we can see the B40 model shown. Shown below is the floor standing system. The floor standing system is designed for larger sized dies or spinnerets, higher volumes, or larger staple fiber spinneret applications. It is designed to be heavy and robust to accommodate larger spinnerets and a larger number of spinnerets. The SpinTrak generates automatic reports. This includes a quick summary of past or failed capillaries and statistics. It also provides graphics of individual capillaries. A graphic of the total spinneret showing the past and failed capillaries are given, and the locations of them are shown. A laser pointer points to failed capillaries for quick cleaning or automatic air purging to remove loose dirt. There is an automatic repeat feature which inspects the spinneret to see the result of air purging. It replaces the light box with accurate inspection statistics. It avoids missing problems not easily seen with the light box, such as change in diameter, damage, wear, partial blockage, which typically still shows light through the capillary. These are typical production problems. The SpinTrak is very helpful in detecting damaged capillaries in production. Here we can see on the left is a capillary damaged. It's also very useful for detecting wear damage in a capillary. Here we can see wear damage. It's also very important that we can find loose dirt inside the capillary, and here shown is a picture of loose dirt. And here is shown more damage to another capillary. Here we can see a spinneret view screen. This screen provides an overall view of the areas where a failed capillary exists along the spinneret. This spinneret is a long Spunbond die. As you can see, the red areas are blocked capillaries. Green represents clean capillaries. Below left, we can see the capillary viewing screen. And below right, we can see the production inspection screen as inspection is in progress. This screen shows the inspection tolerance limits allowed. As you can see, there is a X which selects the type of measurement, and to the right we can see the minus and plus criteria. Here shown is the area, the perimeter settings, the diameter settings, and the profile settings. Improved cleaning helps reduce waste to increase yield and profit. Graphic A represents a spinneret with many dirty capillaries, while Graphic B shows the same spinneret after proper cleaning. Here we can see how the air purging works to remove loose dirt in the capillary. As you can see, the red represents the capillaries that have failed, and it will automatically engage the air purging device automatically and locate itself on top of the capillary, purge the air, and remove the loose dirt. As stated before, a recheck inspection can be made after air purging is made. Here we can see out of tolerance threshold setting example for a spinneret with trilobal capillary shapes. Now we can see a production inspection screen in real time as the inspection is taking place. After each capillary is inspected, the data is shown on the screen in real time. If a capillary has failed, the statistics will appear in red. This inspection is a trilobal spinneret. This graphic profile of a trilobal capillary shows dirt still appearing after cleaning. Further air purging is typically necessary for this type of problem. This screen represents the overall spinneret inspection summary. This is useful for comparing like spinnerets to see which would perform the best in future production. The SpinTrak also maintains a history of all overall spinneret inspection summaries. Because previous inspection results are saved, this allows for a comparison of inspection results over multiple pack change cleaning cycles, as can be shown in the graphic in the middle. Here is another example of an inspection tolerance limits allowed in a trilobal capillary. As you can see in the specifications, it talks about the limits of each leg on the trilobal spinneret capillary. The SpinTrak maintains a library of spinneret types for future inspection needs. Here again we can see a trilobal spinneret. This screen shows a distribution of results from capillary areas inspected. Here we can see the distribution of A1 with inspection results. Typical production problems. Dirty or damaged capillaries can lead to quality problems. Increased damage to a spinneret. Loss in efficiency. Startup problems, delays, or dripping. These type of problems will also result in a lower grade fabric and material loss. There are many benefits to using a SpinTrak inspection system in production. This includes faster startups with air purging or manual cleaning and rechecking, a noticeable reduction of plugging and drips. It helps increase fabric yield by reduction of waste fabric. It helps extend the lifetime of the spinneret, reducing replacement and refurbishment costs. It also helps extend the lifetime of belts by reduced dripping. You can pinpoint problem capillaries quickly and easily, and it provides a positive indication if the capillaries are dirty or damaged. The SpinTrak helps optimize cleaning from inspection feedback when raw material or additive changes are made. SpinTrak is accurate and repeatable inspection. There is an automatic calibration before every inspection is made. SpinTrak provides complete statistical reporting for plant management use. And the SpinTrak eliminates missing partial blockage of capillaries, which often happens with subjective light box inspection.